So as a reminder, when you are trying to find all the roots of a polynomial, you generally follow these 4 steps. Remember that roots are also called zeros or solutions. But the first thing you want to do is the fundamental theorem of algebra. Use the highest exponent, that tells you how many roots you're looking for. Next, you're going to list out all the possible rational roots using that rational root theorem. That gives you a list of numbers just to check and see if they work. Once you find one, the way you can check and see if it works is basically plug it into your equation for x and see if it gives you out a 0. Because if it gives you out a 0, then it's a 0. Basically, the remainder is 0, meaning it divided evenly. So if it works, you're going to need to do some long division with that root's factor, the factor version of the root, and eventually divide or factor what you have left when you can. So we're going to do one really long example here just to show you how crazy this might get. I want to find all the zeros of this polynomial, so where it equals 0, the roots, the x-intercepts, solutions. Notice that it has a degree of 4, so I'm looking for 4 zeros. Got to find all 4. I could just start randomly guessing numbers to plug in for x, but it's probably not the most efficient thing to do. So instead, we'll use the rational root theorem to list out all the possible rational roots. Roots that are fractions, basically. Doesn't include imaginary. Remember, to do this, I'm going to list out the factors of the constant, which would be 1 and 7, divided by the factors of the leading coefficient, which would just be 1 and 5, and do the plus and minus version of each. So that's going to be 1 over 1, 1 over 5, 7 over 1, and 7 over 5. And don't forget the negative version of each of those as well. So these are all possible rational roots to that polynomial. Okay, so let's try some of those and see if they work. Like if you put in a 7, try doing 5 times 7 to the 4th. And 7, I think will work. But what I want to show you is you could actually just graph it. Feel free to use a graphing calculator or Desmos. Here I have the polynomial all typed in, and notice as I look at the graph, it looks like I'm going to have a few real roots. Something here, some sort of fraction, maybe the 1/5 or the 1/7, a root of 1 it looks like, and a root of 7. So that's like 3 of the 4 right there. I'm going to go with 7. So instead of just like randomly guessing numbers on this list, I graphed it so I could kind of cheat the system and see which of these it might be. 7 looks like it worked, so let's try 7. Plug in 7 for x, and you should get out 0 if you do 5 times 7 to the 4th minus 46 times 7 cubed plus 84 times 7 squared minus 50 times 7 plus 7. All of that should give you 0. Meaning it does divide in evenly. It is actually a factor. So that's one of my zeros, a 7. To find the others, I'm going to need to do long division. So if I list out 5x to the 4th minus 46x cubed plus 84x squared minus 50x plus 7, and I divide this whole big long thing by, not by 7, but by its factor, which would be x minus 7. Remember, if x minus 7 is a factor, and I set it equal to 0, it would give me 7 as a solution. So that's why I need minus 7 as a factor here. So let's do, I'm going to go real quickly through this long division. So I'm going to need 5x cubed times x to give me 5x to the fourth. Oops. And this times negative 7 is negative 35x cubed. Subtract, subtract. That's going to be negative 9. Oh, sorry, negative 11 x cubed. And then bring down the next one. And do it again. So I'll need a negative 11x squared times x to give me negative 11x cubed. Negative 11x squared times negative 7 would be 77x squared. And then subtract, subtract. So 84 minus 77 would be 7x squared. Bring down the next one. Do it again. So up here I'm going to need 7x times x to give me 7x squared. 7x times negative 7 would be negative 49x. Subtract, subtract. That leaves me with negative 1x. And bring down the 7. Do it one last time. I'll need a negative 1 times x to give me negative x. Negative 1 times negative 7 is positive 7. Subtract, subtract, and I get 0. If I don't get 0, something went wrong, because I know I was supposed to get 0 as the remainder. Okay, after all that big mess, basically I have what's left. If I take out the x minus 7 from this expression, I'm left with this. 5x cubed minus 11x squared plus 7x minus 1. Let's see if we can factor this, because that's always a good thing to do. Let's try to factor it with grouping method, because it's 4 terms. The only thing I can factor out of this first group would be x squared, leaving 5x minus 11. And out of the second group, all I could factor out is a 1, leaving 7x minus 1. That did not work, because these don't match. So unfortunately, we are going to have to do this process again. I can use my same list, but I'm going to have to do the process again with what I have left. So let me erase some stuff, give us some room. All right. So I have this. I'm going to need to repeat this process. I already have a root of 7. Let's try something else on the list that might work. You can randomly pick numbers, try plugging them in, and see if they give out 0. Or I can cheat a little bit and go look at my graph. It looks like 1 is probably a root, because it hits right at 1. So let's use 1, not try to randomly guess. So if I plug in 1 here for x, 5 times 1 cubed minus 11 times 1 squared plus 7 times 1 minus 1. Type all that in your calculator, and turns out it does work. I get 0. So it is one of the zeros. So we'll add that to our list. We found 7, now we found 1. Those are 2 of the roots, 2 of the zeros. I'm going to need to do some more long divisions. Let me clear this out. So I'm going to take what I have left, which was 5x cubed minus 11x squared plus 7x minus 1, do some long division with the root that I just found, 1. Remember, if the solution is 1, then the factor is x minus 1. And let's do some long division. I'm going to just go quickly here. Negative 6x times negative 1 is positive 6x. And then subtract, subtract. That's gonna, 7 minus 6 is 1x. Bring down the minus 1. Awesome, so now I just need plus 1, because 1 times x is x. 1 times negative 1 is negative 1. Subtract, subtract, and you get 0. Again, I need to get 0, that's what I already found, but the remainder was 0. Okay, now what I'm down to is this, 5x squared minus 6x plus 1. Let's see if we can factor this. It's 3 terms, so rainbow method, 5 times 1. What multiplies to give you 5 and adds to give you negative 6? That would be, let's give you 5. Negative 5 and negative 1. Multiply to give you 5 and add to give you negative 6. Don't forget to divide or slide with the 5. So either divide it or slide it. Here it divides evenly, so I get x minus 1. Here it doesn't divide, so I'm going to slide it over and get 5x minus 1. Here's the good news, we're almost done. These are my last 2 solutions in factor form. To find the solutions, just set them equal to 0. X minus 1 equals 0, which will give me positive 1. And 5x minus 1 equals 0, which is going to give me 5x equals 1 divided by 5, so 1/5. These are my final 2 solutions. Notice, I already had a 1, but I got another one. Remember, I told you that's possible. It's possible to have roots that repeat themselves. That's called multiplicity. So our roots were 7, 1, 1, and 1/5, which is actually exactly what we saw here in the graph. 7, 1, 1, 7, 1, 1, and 1/5. So there were actually no complex roots on that one. That's about as long as these get. I wanted to show you a real full example. I know this is like 10 problems in one, all just to get 4 numbers, but it's combining a lot of the things we've done so far. I want to show you one final example. I promise this one won't be as long. I want to find all the solutions to this polynomial here. So let's start out by noting that there are 3 solutions we're trying to go for. It may be tempting to start listing out the possible rational roots and like testing them out, see if they work, but the first thing you should always try is just factoring. Does this factor? It's 4 terms, so we'll do grouping method. If I factor out an x squared, that leaves x minus 2. And if I factor out a negative 3, that also leaves x minus 2. So this actually does factor. X minus 2, we'll bring that out front. That becomes one of our factors. The other factor comes from x squared minus 3. Okay, and that's it. These are my factors. Let's set them equal to 0 and solve. So set x minus 2 equal to 0, you get positive 2. If I set this equal to 0, it's actually going to give me 2 solutions, because when I add 3, I get x squared equals 3. And when you square roots to get rid of the squared, keep in mind that a square root could be positive, but it could also be negative. And so my solutions here are positive and negative square root of 3 and a 2. So that's 1, 2, 3 solutions, just like I expected.